Hey there, welcome back to the channel. So this will be a shorter video. We are just trying to complete some functionalities and yeah, let's go. So I think the next one was supposed to be try and place. So void try and place pt accept no accept I guess. So no accept and so I need to try that this. Oh, sorry, this. Also, I should be returning to here. And return true. And this is the proof. Sorry, this is the same thing. I'm just going to call it. So we have try, push, try and place. What are some other functionalities that we might be missing? Red dot, that's basically. So we have the constructor, we have employees, we have try and place, we have push, void push. Okay, we don't have this one because I haven't fully understand what it is, but I think we should try it in this one. We have try push, uh, front, pop, DQ first set of the queue. You must ensure that the queue is non-empty before calling pop. This will, oh my god, we should, yeah, definitely. We should definitely try uh, checking that. Yep, I forgot. You must ensure that the queue is non-empty before calling pop. This means that front must have returned a non-null pointer before each call to pop. Wait, you must have returned. You must have a return. You must have returned a non-null pointer before each call to pop because stood is not a destructible value equal to true. Okay, so we are putting. So we shouldn't add check inside pop, right? Okay, fair. So we should be doing that. So if we have size and empty, cool. So we have two things missing, which is we'll be returning, I guess, what we have pushed. Like maybe this is maybe the previous value. So into an item using move construction participates in overhead resolution only if its constructible value blocks if queue is full. So blocks if queue is full. Okay, true. Let's see how this looks like. Like I don't understand like why constructible. What the hell to do? It's okay. Okay, it's fine. Let's look at is constructible. What does it look like? So is constructible constructible CP reference. Okay. I'll add mode. Is constructible, is trivially constructible, is not constructible. So what does that mean? If T is an object or reference type and the variable definition T object uh, declarable variable is well formed towards the inbuilt variant value to true in all the visible response. I don't understand anything of this. What the hell do you mean? So I understand what is trivially constructible might mean. There, so there is a thing called like trivially copy, trivially copyable, trivially constructible. So I think trivially constructible means that when you can construct an object directly using mem copy. So like let's say if you have a big object of 100 bytes and I want to create a copy of that, it can that object can be said that it is like trivially copyable only when I can use mem copy on that. So like I can just, if you're not using any kind of like copy assignment operator or copy constructor, I can directly use mem copy, which is like faster. But I think it might be related to that. It's constructor which is the reference user. So let's see what this means. Verifies whether T is constructible type with a set of argument types specified by R. So I need. So what is it? What is constructible constructible conceivable? Is constructible template. The stood is constructible template is present in type trait header. This is used to check whether the type whether the given type T is constructible type with a set of arguments or not. It returns a Boolean value true if T is of constructible type, otherwise it returns false, header files. This template returns a Boolean variable as shown, so it's constructible. Okay. Checks if int is constructible or not. Okay, it should be. Mhm. Wait, okay, this one was false, and why is that? Why is this one false? This is false. Why is that? And this one is t int and t itself. So, um, okay, and why is that? So t float is non-constructible, declare structures, is constructible. Um, I still don't understand like what it means. What does it constructible claim something is constructible? No, it isn't. The following program appears, following program will compile with either GCC 4.7 or client 3.2 produces 1 as output. Okay, it's constructible. Function prototype. The predicate condition for a template specialization is constructible, shall be satisfied, and only if the following variable definition would be well formed. I still don't understand like what is constructible. Is constructible determines whether there is a constructor that takes the argument, not that the constructor is well defined. Okay. So if there is a constructor present, so let's try something. I'll create a I'll just sleep, brother. What what are the best but what exit? You just yeah, it's active and running. What happened? Did you just change the oh my god, I think my phone died. That's the reason. Okay, got it. So my phone is dead and it's going to take some time for it to charge. But I think we can't use internet for till then. So I'm just going to bring it. So you desktop and then cpp hash include registry and this. So let's say we create a this. So void. Let's create a class A which has a default. So, so class A will have a default copy constructor, and here will have a class D, and we will delete the default copy constructor. So this can be done using this, right? So be this equal to delete, something like that, if I remember correctly. I think there are more variables, but I don't remember them yet. So A, B, B, this should be, wait, it's not allowed to copy, right? So how will it compile? Okay, supply plus plus to C plus 17 member C3 and after and it worked. Damn. So stood out is constructible is how you're supposed to use. So stood is constructible. Right. It's just it's present in five traits. Five traits is constructible. How are we supposed to use that? Is constructible. Uh, I need to give it of type this and then ask for a value. Okay, so value replace a. So does this compile? Let's see. No, it doesn't. Oh, okay, I did not mention do it still. Yeah. Okay, one. So this is constructible. So UTE. Oh, sorry. So find a university. So this should come out as zero. Yep. Okay, got it. So if a default constructor is deleted, so you can't construct that object, right? So if I write BP, this is not allowed. It won't compile. It will give error, right? So call to delete your constructor B. B has been explicitly marked a letter here. Okay, cool. And if I write is trivially constructible, that should be the function. Or is it double L? Yeah, it's double L. Man, Clang is really good at recommending stuff, right? Like I did not see any kind of these things like okay, I understand P is not replaceable. This should be trivially constructible. And if I add another function, C, and add some virtual void, I don't remember like what was that virtual void. Okay, I don't quite remember what I need to write, but just let me see. Find a C. Okay, so C is not trivially constructible, and now it is. Okay, so I understand is constructible, is trivially constructible, and what is the other one that we talked about? Okay, so we need to check that include item using move construction participates in overload resolution only if stood is constructible or T. What is the other argument that it takes? It is returning something of R value. I don't understand like what this is and equal to true blocks is case, right? So it's returning something into an dimension construction. Mm, let's try. So if I add something over here, something similar, let's say p and value, Let's see what kind of things that it provides. It's just taking a okay. So let's see. Use of undeclared identifier P, expected expression, notify right. Uh, mhm. Notify template type P for class A. No, it's the same. Okay. So if I write something inside this, so like void x void t this, so it's not returning anything, but I make it return something, and I also need to. How do we do that? I forgot the syntax. Let me just turn on the hotspot from my phone. Yeah, okay. So Wi-Fi one autoconnect. Come on, autoconnect. One device is connected, which is my aunt's machine, and one Mac machine still isn't connected. Just give me a minute. Look at my screen. Look at me. Look at me. It's okay. It worked. Okay. Visible, visible, visible. Audible, audible, audible. Recording, recording, recording. Cool. So what do they really mean when template tightening P, whatever, whatever, whatever? Okay. There is constructible. Okay. What do you mean? What do you mean? So D arguments must be constructible is not the constructible. You did not create David. It's basically not copyable and not movable. And why is that? This is assignment, copy assignment operator, and this is copy constructor, non-copyable and non-movable. Mm, okay. Try please has it, push has it, and then pop, try push has it. Okay, and what does it mean? I don't know. Nobody knows. We don't sleep on it. Wait, I need to run hitch top, tank top tiger. Okay, so this is done for me. I'll just SSH. Wait, okay. So of course, D SF stands for San Francisco. SF stands for San Francisco. Did I not use system studio start SSHD? Oh, I did not. I am so sorry. No, it should work. Come on. What the IP changed? Okay. Is it 9139? Yes, I do recognize this. Oh, yes. DFQ, DFQ. So we have written almost all of the things that we needed to. There's the basic things. I did not add any safety checks anywhere. There's just no except if you look at Rectal's implementation, it's very established. But I'm happy with how things are going. Okay. So make clean and then make run. I hope there are errors because if they're not, then that's saucy behavior. Okay, let's go. We are doing great. Return statement with a value in function returning void. Uh, okay, line 42 and 40. 42 and 40. Boom. What about try push? It's correct. So this should work now. Only two errors. So 16,000, I think it will be 9,000 or 8,000 and 10,000. Okay. And then 270. Okay, nice. I was about to say 271, but 70 just came in my mind. So it's doing great actually. GG's, we're doing better, but that's not enough, right? We need to test it somehow in a more aggressive manner, right? So how do we do that? Let's benchmark it. Like what all things do we need to improve and all. So rn perf dot data, right? Git status, clean git status. We made some changes, which so git diff. Yeah, right. Git add, git commit. So what commits? What changes do we make? Change names for the pointers. Change names for head and tail pointers. And what was the other change? I forgot. Adding the name member functions. Git push. This was the main branch, right? Yeah, git push. Cool. Okay, so cool. So do we end the video right now? 23 minutes in, and I need to go to dinner. Do we, let's analyze one thing. So like let's do for record. Let me make debug. So perf record debug DSQ. The performance takes a hit when we use perf record. 404 nanoseconds and 1.5 LDF perf data. Cool. Uh, Now we just need to report 50% overhead. Damn. And why is that? 50% overhead. That is crazy. Zoom into debug. I have never tried this. It doesn't do anything. Seriously? Hmm. Okay. Strange. So we need to debug a TSO, use the K hotkey to go directly into the kernel. Okay, K, but it doesn't do anything. Escape. Wait, so if I go over here, browse. Okay, what does browse map details do? Uh, I don't understand any of these things. It inside thread. Okay. So is this the functions that were called something like that? No delete, understand, type traits, PQ, destructor call for PFQ end. This is the entire thing, I guess. Right. Okay. I don't understand anything from this, so no need to look at it. Learn scripts for samples of symbols. Learn script for all samples. Show individual samples. SP. No. Switch to another data file in PWD. Exit. Annotate. Let's annotate. So we are over here. 10.42 something like that. This is null pointer. So we first do what was the code? I forgot. So let me look at the code aside. So cdbfq. Wait, let me get my laptop. Sorry, my another laptop. By the way. I use Arch by the way. I did not. Did I mention I use Arch by the way? Did I mention I use Arch by the way? Yeah, I like Arch. How do you know? Yeah. So BFQ, if I BFQ into front. So we have two load operations. Uh, what does idiff mean over here? So we start from over here, ATX, R38. So this is sub. Hmm, I don't understand any of this stuff. Assert fail. Uh, okay, I need to understand. So like how to read, annotate data along with CPP lines in perf. Because I want like a perf dash annotate. Input file. want- Okay, so perf input file. Sorry, perf annotate input file and then symbol name. Okay, let's try that. So if I go VO QQ, perf annotate. Oh, I remember something. So perf dot data. I have it over here. This just taking this place. And PQ and front. Action for decoding instruction tracing data. Uh, Wait, what's GT? Oh, it's GT info interface here. I'm not going to look at it right now. Performance of profanity, do we want to profanity? Perf report this. G is not associated with good. So I go here, H for key bindings, okay. So toggle showing jump in this circulate percentage to the period samples view, generate script, shuffle source navigation, print to single annotation file, and this. Toggle showing jump file device. Next piece. So string memory order modifier. Is this entire BSK? I don't understand it. Okay, I'm just going to ask a friend first. It's my best friend. Okay, it's getting a bit late. I'm going to get scolded, but just just a quick look. So, next documentation, perf anti, perf data. It's just boring here. Yeah, Safari code. So I will just use it. I have a perf.data file. I found that one of the functions we call takes a lot of time. I used perf report and it showed the percentage to be 50%, but it shows all of the annotations in assembly. How to view them like the line, the code line in CPP, and then the conversion conversion of it in assembly. You can toggle this, but press S to toggle the source code interleaving. Oh, okay. So S large. Okay. So here, this is cool. This is actually really good. So enter edge, we have bit of edge. So front. So this is tail. Where did the tail go, brother? Brother. Where did the tail go, brother? So this is int edge. This is return atomic load. Hmm. Huh? Huh? So int edge top load. This, that, this, that. Look at that. What was the other thing? Press O to toggle object code assembly only. Oh, okay. So O this, this, this. Who's using sequentially consistent? Wait, what? Someone's using that. Someone's using sequentially consistent. That is making our code slow. I understand that now. Okay, so every memory operation should be using relax, should acquire or release to make it faster. Filled, return false, push to remove T, nothing in try push, pop, tail dot load. So the only operations are head and tail. So head and tail are the only ones that are atomic, so I just like to analyze them. So one head, nothing, 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 nothing over here, nothing over there, nothing over here, nothing over there, no tail, nothing over here, nothing over there, nothing over here, nothing over there. Fair, 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 fair. And who's using sequentially consistent? What? Int t is equal to tail dot load capacity. Oh my god. Who's using that? No. Who's using sequentially consistent? So load memory order. Tail dot load, relax, acquire. Okay. Uh, tail dot load this. More capacity. So from to know accept. Can I not just copy this? Yeah. Okay. Help. Um, show full source file print to single name. Oh, okay. I can do this. So I can just do Shift P and it should be present now. If it's present, so if I do this, what do I see? It's a 130 line page. Okay. Cool. So I do have stuff on me right now. Escape enter. I can just do this. I'll just tell. Okay. So hear me out. Okay. I am going to do this. Why did I close the tab and tab? Okay. I am about to give you perf.data for the function that is slow. Don't give me any information of why it might be slow. Don't reveal anything. Just tell me what am I looking at. I understand what I'm looking at. Just tell me how should I read it. Also, is there a reason that sequentially consistent is present when I don't have it in my code anywhere, since I ensured I only use acquire, release, or relaxed? No, you are done. Okay, I'm about to try this. So perf report dash and BFQ specific one. Stood out incompatible file. Okay, fine. I'll do the perf.data. Perf.data. If you have debug info enable, try possible dash s. They did not work on this. Put into a specific this one, select this, flame graph. Ooh, well, like that. Thank you. This, this. Flame graph of PL command not found. I need to install the library, right? Sudo Pokemon dash s. Brendan Gregg. Oh, I know that guy. Brendan Gregg. Brendan Gregg. He's the perf guy. Yeah. Perf script is yeah. I'm just going to do it time because I trust that guy. And cloud. Kind of see how we did that. Or did on the path. I'll just ask it for yeah, do it for me. Give me prepared path. So dash C out at SVG. No stack counts found. Something wrong. Stack count is low. Oh, it's because this stuff stopped. Um, Curve start for debug queue. What is it? Wait, oh, I cleaned it. Oh my god. Mm-hmm. And this called graph stack collection. Dash G still gives empty stack common with otherwise binaries. This, you know, deliver explicitly, dwarf this, whatever, whatever, blah, blah. Then, is it present? Oh. Hello. So we do have an out.svg and I need to get it somehow, or I can just do cd flame graph and open out.svg. Firefox out.svg. Should open it, right? Okay, it did. And it's a horrible graph. Oh my god. You want to look at the graph? So, okay. So debug BFQ, okay, this, and BFQ end. Okay. Let me show you. So this is the flame graph that we have with us. Let me keep looking at this. So this is, I guess, our second calculation for our what do we say? The latency, and this part I think it's for our operations per millisecond because of some difference, something over here. And the reason is uh, I don't get it. 500%, 4.88. Vector allocator operator. Okay, and vector some kind of vector allocation is happening, but I can't really tell you what it is. Okay, I don't understand anything from this, so I'm just going to close this because I'm a dumb person. So I don't understand anything from it. Hello, hello, I'm audible. Yeah. Shift J. Yep. Okay. So I have this data. I'm just going to remove this. And I'm just out of down the RM out of SVG. Uh, RM annotation file. RM prof dot data dot old. Yeah, don't need it. So and then if you and I'm giving you something and the previous instructions. Just let it think on, like what were my base? What were the don't tell you why the function might be stored until you only tell you how to read it. And the perf annotate output, what would you like to know about it? Why is there a sequential consistent memory order even when I didn't use it? So let me try. Let me try. So T front no accept cool. Nothing's much of happening over here. It's better to look at this. It's better to look at this using let's call it colors and all. So no, I'm just going to delete everything that's required. This, delete this, yeah, clean colors like it was. Super report, make clean, perf report, debug recipe. I'm a dumb guy. What is it? Perf record debug recipe. 271. It should have been higher, 400 or something. But okay. So ls, what do I do? Perf report. I go over here, annotate this, do S so I can see the code. Go at the top and just start reading. So no accept 0.6, 3.18 percentage. Wait, first I'll ask, look at this part of the disassembly. This is the memory order value being passed. 0x0 is the integer value of memory order secretary custom. This is for your tail.load call. You are compiled in debug mode. Notice the binary path debug BFQ. In debug BFQ mode, default argument values are not optimized away. So if an atomic load is called, the default parameter memory order sequential consistent is being materialized even though you are still passing memory order interaction with your source. What's happening is the libstd removes this inline chain. Your table load calls into glibc XX always inline load wrapper. In debug mode, always inline is ignored, so it becomes a dual function call. The assert checks this are also running. You can see them in the disassembly checks against this. In release order, all of these processes in a single move or lock instruction with the correct ordering. Okay, whatever, fine. Uh, I mean, I understand some parts of it, but okay. So this is taking some time. Okay, so this was my tail. What is percent? Answer in short. What is percent metric? Consider CPU cycle sequence that landed on that instruction. Okay. Uh, that landed on that instruction. Okay. 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 Got it, got it, got it. So 3.168 instruction on this. We can't really avoid that though. Intel, cool. Let me see yellows and reds. Where are they? So let's return it on blue. So here we have an if condition. So GE means jump, right? What is G? G jump if you call a condition branch. Yeah, cool. So here we test RAX jump. So we do this assert rule and then we return atomic load, right? So let me just do it and then uh, so here we have a if condition where we compare two stuff T and H, which if they are not equal, which is this. So wait, what are these if conditions? So this is memory order. So tail is doing this, I understand that. glibc memory order release, which I didn't use. Wait, this is creating some sus things. I would rather escape into. Let me just change something. So like make file. I'm just going to debug flags dash g, right? Yeah, I don't give a shit. How about that? Huh? And now make clean, make debug, and then we'll create new data. Um, rm perf dot data, right? Okay. So perf record debug bf2 10,370. Oh, okay, it's lower. That's cool. Uh, okay. And then perf report. Yeah, yeah. Annotate and read for the fun. Sorry, I'm so sorry. Uh, I did not ask for that. Did it just like remove everything? So like, okay, and if I annotate move, so move to this and yeah, I think I get it. Like we are not able to understand like what is happening because most of the things are optimized. So okay, let's try to use O2 at least, right? O3 is very aggressive. Make clean, uh, and then the same thing. It's make clean, make debug, O2, talk about, and then perf report. Okay, it's not doing anything. I'm so sorry. Make clean and nothing. Make debug, perf record, and then perf report. Yep, at least we can see some things. Okay, so then there's this, that. And place isn't taking much. Push takes something, but front is the one taking most amount of time. And why is that? Like it doesn't even have like what's the problem? Like push and pop both have like two operations. Why is this like that? Release, last, acquire. Why isn't it this function? This is the one taking so much time. It's it points out. Okay, yeah, very nice. So this is the tail. This is the if condition that we see. So glibc assert memory release. Okay, don't understand that. Maybe something added. Space count tail. Call assert atomic load. Built on atomic load. We are not using returning. We are not returning any kind of atomic load, right? Reference to this to T, then we move RAX, EX, and ECX int H, head dot load. Wait, this entire thing was just tail. Uh, and then there's another thing for head, right? Yeah. Oh my god. And then there's if condition. I don't feel it's taking a lot of time. That's just a bit on. Yeah, cool. Like if this is a move, this compare RPP. So move RPP. So if I get this correctly, yeah, I don't get it correctly. Yeah, fine. Jump to 15D, this, jump to 173, blah, blah, blah. Put it down, give to this studio to alligator, and our studio vector is the PFQ one. Okay, okay, fair. Return PFQ is. So, what I understand is particularly these relaxed and acquired present inside so capacity. Right? I don't think we can optimize it. Okay, I just okay, pass. I give it. I have this function and I don't think it can be optimized further. Don't reveal anything, just tell me if it can be optimized. It can be optimized further. In a, in a significant way on small optimization. Mhm, mhm, mhm. Significant. Wait, what? A very small hint on what is it about. The mod operator. Okay, yeah, cool. Is the mod operation slow? How is the mod operation slow, bro? Fast. If mod operations are slow, I understand that. Ideation, expensive. If capacity were a power of 2, you would replace it with a bit mask. Okay, and capacity minus 1. With a single fast instruction instead of division. Okay, so I need to ensure that um, capacity is operation of 2. Okay, okay. Hmm. How fast would that go? Okay, so if I get any number, so if I get any number and I just make sure that this thing that I'm going to get will be converted to the nearest, um, will be converted to the nearest power of 2. I can't do that, you know. Like, chill, bro. Like the inputs that I'm getting is like I can make mod operation faster. I understand what they are saying, but then it's okay. I'm just going to talk to it again. Hope to explain it like what are the stuff that we're talking about. Like that shit is expensive, bro. What are you talking about? Let me talk in its own language. I understand. But when the capacity is given as 1 million, I cannot round it off to the nearest multiple of 2. It is given the user's choice. You can still enforce it internally down the user's request to capacity of the next forward. Okay. But that is expensive. Even to the modular results and store tail model capacity and head model capacity directly equal to the branches of the variables. Next power of two, yeah. Instead of storing raw head and tail counters and doing model capacity on every front call, store them already wrapped, which stay in zero to capacity and front never needs to divide. Is there a better way to calculate the next power of two for the number? What if the input is 1 million? If n is equal to 0, then this is minus 1. Counts leading zeros, single instruction on x86, this much faster than this. So 32 minus leading zeros, and then this, yep, cool. This is a cool instruction. So I'm adding this in the right weight stuff. Next power of 2. So whenever I get this initial capacity, capacity is initialized, BFQ is initialized. So BFQ size t initial capacity. So I'll call new capacity is equal to what is called next power of 2. So I get this paste. Next power of 2, pass it initial capacity. Yeah, it's a size 2. I don't want size 2. Okay, so yes. And here you can have your size things. Initial capacity, int capacity, and then BFQ, BFQ gets new capacity, and then capacity gets new capacity. Let's see, make green and make one. Strict this cannot be used as a function. Dot reserve. Do I need to use reserve? Yeah, yeah, I understand. Oh, I can directly do this. Directly, I'm done. So next part of two, initial capacity, cool. And then here I can just call and capacity minus one. Let's see, make clean and make run. Let's see. On capacity, okay, I did not do something correctly. Okay, this is what I meant to do. Make clean and okay, it's make clean and make run. 13,000, please be a lot higher, please. Okay, 243, don't sleep on it. Okay, you can see some operations are made. 11,000, and I should get 11,000 again at least, bro. 15,000, that's good. And 249 is cool. But the downside is that whatever user asks for, we are not giving them yet. Okay, so maybe now that we are enforced that, maybe we can change some uh, operations mathematically with something more. So it's going great. Okay, we don't really need a private, and such. 17,000 operations. This better be a lot higher. Okay. Yeah, sometimes it's faster, sometimes it's not, it's fine. I just need to understand like what are the constructible and things that I've done. I think I would add okay, so this is a 1 hour 15 minutes video still. I thought it would be a lot shorter, but okay. So I need to go to dinner. Thanks for watching this video. I'm Vishani and I am engineer for fun. Bye.